This lesson is looking at how hormone regulation happens in the male sex hormones. When we're looking at the male sex hormones, we have to start when we start at the brain level. And when we start there, we look at the hypothalamus. Okay, and the hypothalamus, it releases its own releasing hormone, and we call that gonadotropin releasing hormone, or GnRH. And GnRH, knowing it's a releasing hormone, it's going to act on the anterior pituitary. And the anterior pituitary, because it's a gonadotropin releasing hormone, the anterior pituitary is going to release its own gonadotropins. And the two gonadotropins it's going to release, one is LH, which is luteinizing hormone, and the other one is FSH, which is follicle stimulating hormone. Now, luteinizing hormone is, if you're looking for spelling, that would be LUTEINIZING hormone. And then follicle stimulating hormone is follicle stimulating hormone. Okay, and luteinizing hormone, it's going to go towards the testis, and this is going to act on the Leydig cells. And the Leydig cells are found within the tissue of the testes, and their job is to basically make testosterone. So we're making testosterone. So it's the Leydig cells that make the testosterone. And what tells you to make testosterone is luteinizing hormone, which came from the anterior pituitary. Follicle stimulating hormone, it goes to another part of the testes known as the Sertoli cells. And what follicle stimulating hormone does when it talks to the Sertoli cells is that it tells it to make sperm. So at the end of this, what you have is the hypothalamus releasing gonadotropin releasing hormone, and from there the anterior pituitary then releases its own gonadotropins, luteinizing hormone, which then goes to the Leydig cells, and then the Leydig cells produce testosterone. Follicle stimulating hormone goes to the Sertoli cells, and it tells you to make sperm. So not only does Sertoli cells need FSH, but it also requires testosterone. So in order to make sperm, you need the Sertoli cells being told by FSH, which is coming from the anterior pituitary, but you also need the presence of testosterone in the Sertoli cells to make sperm. You need both of those hormones in order for it to work. Now, the interesting thing that happens here is that we have a negative feedback loop. And the negative feedback loop and positive, so the more GnRH that's released, this is positive feedback, so the more GnRH that's released, the more luteinizing hormone. The more luteinizing hormone in FSH that heads down, you're going to, if you have high levels of luteinizing hormone, you're going to make more testosterone. If you have high FSH, you're going to create more sperm. But what happens is, as the Sertoli cells are making sperm, they're also creating another hormone known as inhibin. So it's creating another hormone called inhibin. Okay? And inhibin heads up to the anterior pituitary, and it has a negative feedback loop. So if you recall from negative feedback, what's happening is the higher the inhibin levels, it's sending a strong message to the anterior pituitary to stop releasing the FSH and LH. So that's going to counteract. Testosterone also has a negative feedback to the anterior pituitary and the hypothalamus. So they have negative feedback, and this has negative feedback. So the more testosterone that's made, it's telling the hypothalamus and the anterior pituitary, well, we really don't need any more testosterone, we have enough, and it's going to shut it down. And as testosterone levels drop, that's going to basically restart the hypothalamus to start releasing GnRH and the anterior pituitary to start releasing luteinizing hormone again and FSH. So in a nutshell, the hypothalamus, GnRH, luteinizing and FSH from the anterior pituitary, LH goes to the Leydig, Leydig produces testosterone. FSH goes to Sertoli, Sertoli goes to make sperm, and it also makes inhibin. Inhibin and testosterone both have a negative feedback onto those the glands that secrete LH and FSH. Hopefully that makes a lot of sense. That's basically the male sex hormones and how they feed back and how sperm is made and how testosterone is made.